look at today's assignment. So first of all, you read what it means to talk about the vertex of a quadratic function. So it tells you the vertex of a quadratic function is the highest or the lowest point of the parabola. And you may remember from early in the year when we talked about minimum and maximum values of functions. So for this parabola here, the vertex represents the minimum of that function or the lowest point on that parabola. And for this parabola, since it's opening downwards, this highest point represents the vertex. So it's just the point where the parabola starts to turn and go in the other direction, whether it's going upward or downward. Okay. Now there's a special form of a quadratic function. Instead of the standard form, remember standard form was ax squared plus bx plus c equals 0. That's the standard form of a quadratic function. This is called the vertex form of a quadratic function. And as you go through these questions, it makes sense about why they call this the vertex form. So let's look at these questions. So they tell us the vertex form of a function is here. So if you look at this equation right here, y equals 3 parentheses x minus 5 squared plus 4, that matches the vertex form here. So that's written in vertex form. So let's see what that means. So it says use the graphing calculator to graph this equation. So let's go to the Desmos calculator and graph that first function that was 3 parentheses x minus 5 parentheses all of that squared and then plus 4. But stop right there for 1 second. Notice what happened to the vertex. If it were just x squared, it would have been here on the origin. Notice where it moved to. It's now at 5 comma 0. Okay, and let's finish that up. It said plus 4. Plus 4. Now watch what happens when we add the 4. It moved the parabola upward, didn't it? And that should remind you of like the y-intercept in linear equations. That plus 4, if it were 2x plus 4, that means the line would be passing through the y-axis at 4. Well, the plus 4 here tells us that the parabola just shifted up 4 units. So we're supposed to graph it and then find the coordinates of the vertex. So that point right there is at 5, 4. So let's go back here and write down that the coordinates of the vertex are at 5, 4. Okay. On 2. Let's graph this one and see what happens. So now we have y equals 2 times x plus 6 parentheses squared. Notice what happened when we did the x plus 6 in parentheses. Notice where the vertex is. And then we had plus 5 at the end. And what does that do? That looks like it moved it up 5, right? So that vertex is at negative 6 comma 5. Okay. So for the second one, it's at negative 6 comma 5. And then let's look at the last one and then talk about the pattern that we see here. So on 3, we had to graph y equals x plus 2 in parentheses. And all of that squared. Well, notice what the x plus 2 in parentheses did. Notice where the vertex is. It's now at negative 2. And then we had to subtract 4. And what did that do? That now moved the point to right here. So we see now that that vertex is at negative 2 comma negative 4. Okay, so now we've got 3 vertices for those three parabolas. Now 4 is telling us to look at this and make us and asking us to make a prediction before we actually graph it. We'll go back here and look at the patterns here and see, is there a pattern that you see that you can follow to make a prediction without having to graph it? So your h value, since it says x minus 5, do you agree then that that means h equals 5? And since it says plus 4, that means your k value is 4. Alright? Look at the vertex, 5 comma 4. So what did the h equals 5 represent? The h equals 5 represents an x coordinate of 5, and the plus 4, your k value of 4, represents a y coordinate of 4. So the vertex is at 5, 4. Alright? So notice it's saying minus h here. So since it says minus right here, that means your h value is just positive 5, not negative 5. And that's the one thing that's sort of, to me, counterintuitive to this equation. Because when I quickly look at it, I think that minus 5 means I would be moving 5 to the left. But actually, that just means your h value is positive 5. So that means actually move it 5 to the right, which gives you the x coordinate of 5. Right? Does the same thing happen on number 2? It says x plus 6. Well, if it says x plus 6, and if you want to put it in x minus h form, would you agree then that that could be written as 2 times x minus negative 6 squared plus 5? You now have written it as x minus h. So if it's x minus h, what's your h value? Your h value is actually negative 6. So for that to be x plus 6, that means your h value had to be negative 6. That's when it starts to make a little bit more sense. So if your h value is negative 6, and your k value is 5, what does that mean? That means that the point of the parabola moved 5 to the left to represent the negative 6 on the x-axis, and it moved 5 up to represent the 5 for the y-coordinate. Okay, and then on the last one, since it says x plus 2, you can rewrite that as x minus negative 2. So that gives you an h value of negative 2. And what's your k value? Your k value, that's the same as plus negative 4. So that means your k value is negative 4. So your h value is negative 2. Your k value is negative 4. And when we graphed it, that's exactly where the point of the vertex was. It was at negative 2 comma negative 4. So now looking at this one, since we've got x minus 7, the 7 represents the h value. So that makes me think, all right, h has to be 7. And since it says plus 3, that means the k value is 3. So that makes me think that this would mean the parabola went 7 units to the right to give it an x coordinate of 7, and 3 units up to give it a y coordinate of 3. Right? So now let's actually graph it and see if our vertex is actually at 7 comma 3. Okay, so we had y equals 4 times x minus 7 in parentheses, all of that squared. Looks like it moved a 7 to the right, like you were thinking, hopefully, and then plus 3. And then obviously that moves it over to 7 right here, and then up to 3 on the y-axis. So yeah, our vertex for that parabola is at 7 comma 3, just as this pattern predicted it would be. So yeah, that then tells us, if we have this equation written in this form, that explains why this is called vertex form, because just by looking at the h value and the k value, we know what the x and y coordinates are for the vertex. Alright, so that's just looking at quadratic equations. Now we were to look at, I didn't copy the title, but this is talking about cubic functions, right? And if you look at these equations, it makes sense about why these are called cubic functions, because look at the exponents. This is x cubed, x cubed, x cubed, x cubed. So functions where you have an exponent of 3 are called cubic functions. Exponent of 2 means quadratic. So let's graph these and see what they look like after you graph these. Right? So let's put these all on the graphing calculator. We have y equals x to the third, and if you need to make an exponent other than 2, use the a to the b power key. So if you press a to the b, then you can enter the exponent of 3 that you want, and we see this shape for our function. Interesting. You see how it's sort of like this side of the parabola has been flipped up. If you reflected it back across, you see how it would go down and match the other side, right? Right, the next one was y equals 2x to the third. So 2 times x to the third. Okay? And then we had 4x to the third. Interesting. And then you had 10x to the third. Okay. Notice they all have something in common. Don't they all have that same general shape where it's like curving as it goes upward, and then it changes directions and starts curving upward the other way? Okay? So what did it ask us? Notice x to the 3 is the red one. And then as the numbers increased, we got to 10x to the third, which was the purple one, which was here. They all have that same general shape, but notice the purple one, how can you describe that compared to the red one? Couldn't we say that the red one looks wider than the purple one? That should remind you back when we were talking about stretching functions. You may remember that when we were looking at rational exponents. But yeah, we could say that as the coefficient, as the number in front of the x got larger, the function got thinner, didn't it? Or it got stretched. So that's what we want to talk about. As the coefficient increased, as we went from 1 to 2 to 4 to 10, the function got thinner. The graph of the function got thinner. Okay? And now it's asking to graph these functions all together. And notice we have 1x to the third and then 0.55, 0.2, 0.1. So now we are seeing the coefficients get smaller and smaller. You probably already have a prediction, or you may have already made a prediction before you did this. So let's see what happens with that. So the first one was, we're still starting with x to the third. Okay, and then we had 0.5, oops, we had, on the next one we had 0.55 x to the third. So there's the next one, and then we had 0.2 x to the third. And then 0.1 x to the third. Okay. So our original x to the third, the parent function was the black one here. And then notice as the coefficient decreased, as it got smaller, and we got all the way to the purple, what happened to the shape? As it decreased, couldn't we say that the function got wider? Okay, so the graph got wider. as x decreases. Okay? And then the other kind of function we looked at was the absolute value function. Okay? You can also have functions that are written like this. We don't have any exponents anymore, but now we're just taking the absolute value of whatever x is, and there is a pattern that you see when you graph these. Okay, so when you graph these functions, y equals absolute value of x. Let's see what these look like. So the first one, your absolute value key is here, so press the absolute value and then enter x. Then you can press it again. So it creates a V shape. Okay. Well, then what happens if you multiply 2 times the absolute value of x? Get the red one. Still a V shape. Notice what's happening. And then we have 5 times the absolute value of x. Still a V shape. It's getting thinner, isn't it? You're already seeing a pattern again. The nice thing about all these different functions is you notice like similar patterns, like the same kinds of things happen, even though they look different. The same sort of things happen. As you increase the a value or the coefficient, you're noticing something is happening just like before on the other functions. Right? And then the last one was the green one here. So the coefficient, and we call these numbers, these coefficients, we call that the a value, just like when it's on ax squared. Well, this is the a value, 2 is the a value, 5 is the a value, 10 is the a value. So what happened as the coefficient or the a value increased, the graph got thinner, didn't it? Right? And then on the last one, it said just try graphing some more absolute values, absolute value functions with coefficients that are less than 1 but greater than 0. Right? So that just means fractions or decimals. The ones I thought about were I thought about doing 0.9 times the absolute value of x, and then I thought about doing 0.6 times the absolute value of x, and then I thought about 0.3 times the absolute value of x, and then 0.1 times the absolute value of x. Okay, and see what happened there. So the first one I changed to 0.9. And then the next one I changed to 0.6. And the next one I changed to 0.3. And then on the last one, we made that one 0.1. Right? And let's go ahead and do just x again to show y equals the parent function without changing. Right? So the purple one, again, there's your original y equals absolute value of x. So then as you decrease the a values as they get less than 1, 0.9, 0.6, 0.3, 0.1, notice it goes from here to here to here to here. They get flatter, don't they? Or they get wider. The V shape gets wider. And that's probably what you predicted. Yeah, so the graph flattens out or it gets wider are two ways you could describe that. Or it gets wider. Alright. So there are some quick introductions to other types of functions that that you'll see more of when you get into high school, but it's good that you are at least a little bit familiar with them, okay?